The fastest way to make your RAG app worse is to retrieve more documents.
And the easiest way to make it hallucinate with confidence is to retrieve too few. That trade-off is top K.
So this tiny parameter looks harmless, but it can decide whether your system feels smart, slow, or just wrong.
Exactly. In retrieval augmented generation, top K means how many documents or chunks you pull back from search before the model answers.
Which sounds almost boring until you realize that number is choosing what the model gets to know.
Right. Set K too low, and the retriever may miss the one chunk that actually contains the answer. Set K too high, and you flood the model with extra text, noise, cost, and confusion.
Give me a real case, because this is where teams usually get casual.
Picture an internal doc spot for a payments company. A developer asks, how do I rotate webhook signing keys without downtime? If K is 2, you might retrieve the general key management page and an old webhook doc, but miss the migration runbook that explains the overlap window. The answer sounds reasonable and is still operationally wrong.
So low K does not just miss context, it can miss the one detail that separates safe from dangerous.
Yes, in RAG, relevance is often spiky. One chunk can carry the critical sentence, while nearby chunks look similar but are incomplete.
Then the obvious reaction is, fine, crank K up and stop missing things.
That helps recall, but it creates a new failure mode. The model now has to sift through more text, some of it weakly related, outdated, or duplicated. More context does not always mean more signal.
And once the prompt gets crowded, the answer can drift toward whatever chunk is loudest, not truest.
Exactly. Think of retrieval as opening the door. Top K controls how many people walk into the room. Too few, and the expert is missing. Too many, and the expert gets drowned out.
Let's make the cost pain concrete, because this is where a prototype turns into a budget problem.
Say each retrieved chunk adds 300 tokens after formatting. At K equals 4, that is roughly 1,200 input tokens. At K equals 20, now you are around 6,000 before the user question, system prompt, citations, or tool instructions. Multiply that by traffic, and a retrieval tweak becomes a bill.
So one team ships a crisp assistant, another ships a slower, pricier assistant that still answers worse, and the difference may be one number.
Yes, because higher K also increases latency. More search results to fetch, more context to assemble, more tokens for the model to read. Users feel that drag immediately.
There is also a strategic angle here. If your competitor answers in 2 seconds and you answer in 8 with more mistakes, users do not care that your recall curve looked better in a notebook.
That is the right framing. Top K is not a benchmark trophy. It is a product decision, balancing recall, precision, latency, and cost.
How do you explain the quality drop to engineers who think the model should simply ignore irrelevant chunks?
Because models are not perfect filters. If you mix 5 useful chunks with 15 almost related ones, you create distraction, contradictions, and false anchors. The model may merge them into an answer that sounds polished, but is less faithful.
Give me another practical scenario. Something teams can picture in production.
Take a support bot for a SaaS product. A user asks how to export audit logs for a specific workspace role. With K too low, the bot finds the generic export article, but misses the permissions node hidden in a role-based access page. With K too high, it drags in old admin docs and enterprise-only features, then answers with steps the customer cannot even see.
That is nasty, because both failures look competent. One omits a blocker, the other invents a path.
And those are the expensive failures. They create tickets, erode trust, and make engineers blame the model when the retrieval setup is the real issue.
So what is the practical move if you are building this now and do not want to disappear into benchmark rabbit holes?
Start with a modest K, often in the low single digits, then test on real user questions where missing one key chunk changes the outcome. Look for the smallest K that reliably surfaces the needed evidence. If quality stalls or drops as K rises, that is not surprising.
So, the goal is not maximum retrieval, it is enough retrieval.
Exactly. Top K is not about feeding the model everything you found. It is about protecting the answer from both absence and overload.
And that is the twist. In RAG, smarter systems are often the ones disciplined enough to say less.